Okay, so welcome everyone to this new episode of EagleFly, the experimental debugger, and we are set to go. We are gonna start this new episode opening for coder. Of course, it's 4, not 3. Now we compile, and if I do remember, the last thing that we did was that we added the kerning spacing to fonts, although the thing was not like totally correct, if I think, because let me see. I will open MS Stuff. Now we run the code. And yeah, please run the code. There you go. So that's the last thing we did. And I mean, it looks fine in most of the cases. But there are some like pitfalls here, like for example the H and E and looks a little bit busted there. And let's try with something, a text that probably can be more of a representative. So let's see if we can. We don't need this anymore, you say? Probably we don't need this anymore. Alright. Now I know what to write here, but I thought there's there's some things that they put into the. I don't know if it's in. Let me see if I can find it. What? Is it like this? There you go. And now I say that I want, and I want normal, and yeah, this is gonna work. But I cannot well, I can type it. For guys that you don't know, it's Spanish. Sorry, yeah, it's Spanish. Basically, this says the the fast. How's called this? Fast bad. The fast in the battle. It's happy. I don't know what's that, but I don't know what's that in Spanish, man. Forgive me for that. And kiwi, if you know what's kiwi. And I don't know what the hell is going on, but I think that's good. I mean, and I believe that we don't have that, so probably that's not gonna do it. But we can see. Yeah, because we just load from 555, so we're not gonna get that at all. But for example, something like that. Oh my god. Well, that makes total sense, I guess. Oh, it was not what I thought, but fact code point so big, is that because yes, we don't handle that for now, so probably we shouldn't do it. But right now we are at it says so yeah. So we also want to do that correctly. El velo. So what I would say is that let's start by moving this upwards so we can start like, you know, like a normal text editor that puts that starts on the top left and goes downwards and to the right. So what I would say is that instead of doing this like this, I would say that is frame buffer height frame buffer height minus white balance. Of course, this has to be right here. And this is for the font. Deluxe. I believe we set something like this. Alright. So I don't know if that's a lot. So probably it's a lot if you think about it. Or probably that's alright. I mean, the code point itself, it's too huge. Let me change the code point size. And probably, yeah, I mean, probably we want to change this. I mean, the way that the API works is that you specify a high that it's gonna work. I mean, this is pixel in pixel space, and I mean that works fine for modifying the. I mean, it works like in scaling, but how can I translate the scale to the let's say to the code point size? That probably is more like what we want. So I know probably something like um, if I do remember, we had it in the Milton. Let's open Milton. Now let me see, where do we have the translation? I believe it's this one. Yeah. So these are the 72. Oh. Points per inch are 72 and pixels per inch . Where are you? Okay, here is it. And this was the way that we could do it if we have the coordinates in pixel space and want the coordinates in the matrix, well, in the matrix, but this is called, no, it was the master. Yeah, this is the coordinates in the master and the coordinates in the pixel. So I don't know if this thing has, let's see, no, TTF, yeah. Because you think about it, I mean, across, I mean, they look fine, although we probably want the baseline so we can render correctly, for example, the G and the and each one, I believe. So we should, yeah, so that all the, I mean, we had to get the baseline. But let me remember if, where was it? So for example, he uses the baseline from the vertical matrix. And the thing that I was looking at is that when he used, there you go, here's the 79. And this is the 70, oh, but this is 72. Well, I thought the 79 was because of the Unix branch that we haven't, but I guess it's not. So for example, if I move this a little bit, so that instead of having that hugeness, alright, super little. I don't know if you guys can see, but I can even try to use, how's it called? Jesus Christ. Zoom it. I can start to so you guys can see it. Whoa. Yeah, I mean, this is totally busted. Okay. So yeah, first of all, we'll need to get the baseline correctly. That's the first thing we should do. So let's try to do that. I didn't know that we had a point, yeah, the cursor pointer to be like that. Well, probably it's in the, yeah, in that thing that when we zoom, probably the program changes the cursor. Alright, so let's get the baseline so we can do this more properly. And let's see if that goes well. So the baseline, probably we got it from here. And you know, instead of having this y advanced, we probably say, you know, the baseline. Oh well, probably we can do this like this, so we can test it. And this is just gonna be like this. And what was it? How to handle space glyph? Well, yeah, that's what we are doing. So yeah, we got the baseline basically, and if we want to draw them correctly, I guess we will need to, I mean, I don't know if it's gonna be better to get, imagine like if we got a G, let me zoom. So imagine that we have a G. I'm gonna put the day because why not? Day, what's this day? Day 29. Well, since I'm not like, I mean, all the streams and videos are like, they're not based on days because probably sometimes I make 2 videos per day or something like that. So sometimes I don't make any one. So yeah, it's kind of not cool to be days. So probably we want just like this. This is all 30, I believe. Alright, 030, and yeah, so the thing that I was looking at is that probably we, oh, Jesus Christ. I mean, if we have a G and we got the bitmap, so imagine that this is the G, and forgive me if I draw it totally busted, but I'm not even I'm not good at doing this stuff. Okay, so for example, let's say that the baseline should be there for the G, and then the A, oh Jesus, you know, the A is gonna be something. This is a capital A. The baseline should be on the bottom part, so we always want to get that, you know. And normally it's, I mean, this is the ascent, you know, this is the ascent, the one that we got from the ascent. So right now what we are doing is, I mean, we don't have any kind of spacing at all, because what we do is we have this coordinate at all, and we draw the bitmap
as a position of this, you know, and then we move by the wide bands and we position the other, you know. So we do this, and let's say, and let me see if I can catch this, you know. Probably, yeah, I think that can work. The only thing that I want to look at is that the right here. Oh, of course I cannot enter there. RAM. Are you serious, guys? Oh, there we go. Alright, so we got the H advance, but well, we modify it by the scale. And the H advance is 8.9 pixels. 8.9. Alright, and then we get the glyph, and the glyph itself should have a width and height. Well, the glyph there you go. It's the width is 8, and the H advance is 8.9553, and the I don't know. Oh, that probably seems fine, but let me. So we have 8.95, and the code point is 69, which I don't remember which one is, but we can take a look. It's the E. Alright, so then the position at X and at Y, it's 524.56, which is fine. I mean, what we basically want to do is to move the baseline so the baseline matches everywhere, you know. So it doesn't matter if you are drawing from here. We always position correctly each bitmap based on its own baseline, you know. So that means that probably this was not correct at all. Let me, oh, I don't want that anymore. And the thing where we got that it was here. So where is the Y bands? Here you go. So we have it here, but probably we don't want it there, and it's more like about here, you know. I mean, we're gonna position each independently as we need it. So I guess something like this. I want all the metrics, you know, probably the white bands and the baseline and the, let's say we want also probably this, more like this, because this is gonna give me more flexibility. In fact, I can take rid this and I can get ascend, descend, and line gap. And this can be well, that's good. So the cool part is that we have the x offset, y offset, which is probably the same as, I mean, that's in the bitmap, so it's already scale. I mean, it's already in pixel. This is in pixels. Let me put it. No. These offsets are in pixel space. Can have something like this, and how big the asset bitmap is. It's in the platform. It's 5 days. Okay, it's a little bit huge, but it's okay. Okay, so if we go back and we got the ascend, the descent, and the line gap, we could try to use the x offset, I believe. Let me see where we got that. X offset. So yeah, what we're gonna do is we're gonna measure it. I mean, imagine that this is the baseline. Let me draw it more clearly so we can see it. What I'm gonna do is this. Oh, well, I'm gonna put the G right there, and I wanna. I mean, imagine that this is when we move. This is the top, you know, like this right here is gonna be the top of the window, and this right here, it's y bands. Y bands, and this is gonna be the baseline in y bands. So each bitmap has to be positioned correctly onto that baseline, you know. So for that, what we need is some way of knowing since we get this position and we get this position, we'll need to get it based on a subtraction that is basically a vector, you know, this vector right here. Well, probably it's this vector, yeah, because we're getting it from there. Although, yeah, because we what is the y-offset, yeah. So we can probably do this like this. So let's try it this way. You know, we have y-bands, and that's correct because that's what that's what we did here. I mean, the point here is that, I mean, the ascent is not the same for each code point, isn't it? Where is it? Let me see. Each ascent is specific to each glyph, I would imagine. So let me put it right here back just to see it, because I want to store that. So let me go here, and I want to go back to where we get the wire bands. That should be here. So the ascent, let me put it here. Ascent, descent, line gap. There you go. It's something crazy, but probably that's because that's not scale. (1854) 436. And the white balance is like about 15.43 pixels. Or probably yes, it is, because this is not specific to a code point, isn't it? So probably we are correct, just we are missing the offsets. Get point, each matrix. Yeah. So yeah, I mean, we got it right. I mean, the only point here is that we don't need probably this right here. We just need the x offset, y offset to be represented into the place where we want. So if we get it here, I believe. Here you go, we got it. And then we just need to set it on here. There you go, we already got it. There you go, we have the x offset and y offset on the glyph itself. So we all need to do is to adjust here. So every time we move the add y, you know, we can do it here. and we can say that since we started by moving one wire like bands, every time that we want to adjust the add x, you probably don't want to modify the add x, but probably, sorry, the add y. The add x probably, yeah. Probably, yeah. So what we want to do is to have something here that's something like this, and it's something like add y, and then and probably this is the reference, and then what I want to see is that instead of using add y, I want to use y position, and then add x, probably also that, and instead of getting the get a check bands, I want to get, probably we can do it in get a check bands, so we don't care. So what we want to do is to get the glyph. We get the glyph from the table, and then here you go, we already did it, but we didn't do it correctly, isn't it? We just did it for x, but we want to do it for y. So probably we want to return more of this, and we want to return something like this. So we probably want to do something like this. Since we got this vector, but we want this vector instead. So we want to translate it. So we want to say that we got the glyph height minus the how can I say, the glyph y offset plus, that's one, and then it's the glyph and probably, I mean, we don't just really want the height, yeah, because if we modify the width, we would start drawing it here. Probably that we don't want that. Well, let me try. If we see it's kind of janky, we take it out. So the width, sorry, the oh, this is correct because it's in x, so this is gonna be this is gonna be that. So this is the vector basically. So we can do something like this. How is call this? Reference, translation, relative vector, let's say, and glyph. There you go. And then what we have to do basically is to translate it. So we just say this, you know. So it's going to be a vector from the at x at y, that it's this point, plus this vector. Well, in fact, it's put as a plus because it's already in the same position. No, it's a minus. Sorry, yeah, it's a minus, so we can move it. And yeah, I believe that's gonna get it. And this is more like get probably want another call for this, you know, so it's like internal vector 2. I mean, this is correct, but probably so this is like get h advanced.
Glyph. I'm gonna need this. H advanced, I remember. So let's see what we got. So right here what we would do is to get the position So probably just get next glyph position. This would be just px py. There you go. And this is fine, I guess. And let's compile. And we don't have a minus, don't you? So we should implement it also as well. And we should implement like everyone. Probably this is like a header mark. And well, yeah, I'm gonna so let me just see what happens if we run this. So we had the metrics that are the same. We know this is like white bands, so we move by 15 pixels, 15.5. Got the mono bitmap. And what's the x offset, y offset? Well, this is the normal thing that happens. Let me add for the next. What is the x offset? 1 and minus 10. Okay. So we have x offset, y offset, and we have the width and the high. Okay, so that seems fine since it's like a total, it's gonna go totally downwards. This is exclamation mark. And what else? Oh, but look, this is minus 10. Well, yeah, it's the thing that I was looking. So what if we... How do we implement it? You got a minus, you say? So it's a plus here. Since it's, yeah, because it's already negative, we just need to add it so we get to the right position. Right. And let me put it, I mean, this is busted still, but let me zoom it. Let me put another code point size because I cannot read too I cannot see very well. So let's say we have a 40. There you go. And you know, probably that's not correct since we didn't move it all together. And it seems even faster because it looks like if it moves, I mean, it worked, but it worked not the way that I was expecting. So let me see. And let me try to, well, before doing that, so probably it's not the offset itself. That is the one that we should use. Let me take out from the equation the x offset since we don't want that. Alright, that seems better. Oh, and of course if I put it on the correct position, alright, that's better. That looks very good, you know. Now we move the G's, goes correctly, gets aligned to the baseline correctly, the Y's correctly also, the F's go upwards, which is correct, the D's all looks fine in that line, which is really cool. I'm sorry. So that's really cool. So now let's try uh, to move the, how did I say this? Uh, to put another text on down so we can see how it goes. So we can go here and we can say that render to text, and probably we can say text, we can print the same, I guess. And of course wait, it doesn't happen to, oh, and every time, yeah. So I don't know if we want to do this way, because I mean it depends on how the program should do it. Because imagine that we don't know. I mean, we should take care about if we want to. Um, Imagine that I put in this text, and then I want to print. Uh, yeah, imagine that we want. I'm sorry. Imagine that we want to print this text, and then we want to print some more text in, like, up onto the next, on the same line, I guess. So we want to have that flexibility, although we don't know. I mean, we don't know how we're gonna manage to control text. I mean, because there's many ways to go in that route, and it all depends on how the UI system is gonna work. Which is, I mean, that's a really interesting problem. And yeah, so let's say for now, I mean, we don't. It's gonna be totally janky, but I guess we can do this. Right here. Oh, and we forgot to. I mean, this is not plus but minus. All right. So that seems fine. I mean, the spacing looks really good. I don't know, for example, this W and this I looks really close to each other. The others are really good. They have nice spacing.
But yeah, have some nice text that now it's good aligned, which is nice. I don't know if we want to do it this way. Should be the same. There you go. And now what I would like to do is to oh, look at that, man, this is special, man. Today is a special day. Can you see? Oh, Jesus Christ. Well, I mean, it's gonna be recorded, but man, if you guys were really paying attention, you could see and it's, I mean, I think guess it's because Windows, but it's like this red pixel that gets happens to appear everywhere. I mean, that's so funny because Windows has this kind of stupid way that it renders stuff, so that I don't know. I mean, I don't know what happens, but I always appears on the screen. It doesn't matter where you are. The red dot is gonna appear somewhere, and you never know. I mean, it always appears totally randomly. So it's kind of crazy. Okay, so let me drink some water. Okay, this is good. Today I drank some milk with my friends. Yep. Of course, if I spell correctly milk. For example, the O has some nice kerning in there that it's really entering in the T. The I, well, it looks fine. I don't know, but the T and the H are a little busted there. I mean, they're not overlapping, but they are really close. Too close. But yeah, the F and the R. So yeah, I mean, there's like these caveats in there. And the kerning, where's the kerning? So yeah, especially in the, oh, it has that nice kerning. But for the others are kept the same. And I think that I got it wrong, but let me see. No, that's not the way it goes. That looks perfect, man. That looks really neat. Although, I mean, the eye now it's good. The eye, this FR thing looks good. I mean, I know it's this cheesy thing that I put here. Although, let me see if it's here. No, it's not here. I mean, you can see some spacing in there, which is because of the offset that we set. But man, that looks really nice. And probably the reason is because I mean, we are adding this as an offset, which is not totally correct at all. But man, I mean, they look really, really good. So probably we'll keep it that way, you know. Yeah, we're gonna get this offset here because of that. But without it, I mean, if we take it back, you know, can even try to do this. Like this, you know. And then what if I do this? Oh, of course this has to be. I think that's the correct way. But they are too close. So the thing that I don't know, probably we want to keep it that way, and then put it to do. Okay. So the thing that I was looking at is that we can now we have this kind of the same thing going on the same, like, I mean, you can see here like get edge advance, get next glyph position, and get glyph from compound. Basically all have this kind of same structure. So what I can do is to they never implemented this with me. There you go. Spell a glyph. So what I can do, something like this. I'm sorry. And this is gonna be like, we got the edge. Let me see. Where did I put it? get next glyph point, glyph code point, get kerning for pair. So probably this can be like this is the table, and then we can say okay glyph. Do we also glyph metrics, I guess? I mean, because we're gonna return the glyph itself, so but it's intended for that, I guess. Yeah, that's fine. Yeah, that's fine. And this is gonna be this, then something like this. So then this doesn't care at all about this, anything of this. And it's just like, so need this and also need that. And we can keep this, and then we have calculate metrics, then we have debug state, basically what's gonna need everything the same, glyph something like this, and we don't need that, we need this, there you go. It would be the same from this one. Probably this can be called position glyph. Yeah, position glyph. And then this is gonna be the same, we don't need this at all. This can be this, and this don't need, you just need that, and yeah, this is gonna be, how it's called, the same as this one. There you go. And the same for this one. Let me copy all this stuff. I like it that way. So yeah, I believe you compile this. It's not gonna render anything at all because that's what we supposed to do. Let me see what we did there. T-book stage. I don't see any problem with that. I don't see anything weird going on. We can position the glyph. Oh, is this not correct at all? Oh yeah. A glyph from coupon. And then we add a root. Let me see. Okay. So let's go to the code itself and see what's going on. Alright. This is 0 and this is 4016. 4098, and we want to render that. So for now the add it's an E. So we should get a kerning. Oh, what did I do there? We got for the kerning, and it's like, well, give me the kerning, please, if you mind. Well, probably someday we're gonna get it. There you go. And we got that the kerning it's 0, which is fine. The perform kerning value, that's correct. So that didn't change at all. What about this one? We got the glyph. Give me the glyph matrix. We got a coupon. We saw
of index to the 38. So we're gonna get this, and then we got this. Oh, and of course, we're never gonna get it that way. There you go, we're back. We are back. And yeah, I like the way fonts go. And it was such a so simple to gather with the help of Mr. Chomberg. That's what a good API does. Simple to get stuff done. Alright, so let me go. So what should we do now? We got some text. We can go. We can. We have. We don't have pretty much anything, but we can go back and forth. We can go back and draw like lines of text, as we would like to do. And sometimes this can go crazy, yeah. There's too many routes that we can go, we can start doing the UI itself if that's what we like to do, or probably it's not such important right now to get the UI, because we don't know how we want to present the data, because we don't know what data we want to present, and that's really important. That's really important to see. So I think that what I'm tempted to do is to get first the data, and see what we can do. My first point of view, and the thing that I've been like thinking about this problem. Let me explain it to you, because this is really important. We got the fonts, and the fonts is the only reason that we did fonts first is because we just want to. Once we get the data, we just want to see it, somehow, in a really simple way. So, yeah, let me go to Milton and explain to you the plan, the interesting plan. And in fact, I don't need Milton. I can show you here. In Visual Studio, the debugger, the Windows debugger of excellence. So you can see here. Let me put a breakpoint somewhere, right here. And I set a breakpoint. There's a clear notion of what Visual Studio Debugger does, and the way it does it. A debugger basically it's a tool to a visualization tool. That's what in essence a debugger should be. It lets you visualize the code in different ways, so that you can see different perspectives of the same process going on around, and finally what that lets you do, and what that lets you know, is the problems and the caveats inside your code base. So that's the really basic of of debugging. You know, Uh, that's like the cornerstone and what every debugger should allow to do. And of course, it has to be simple. It has to be uh, reliable, fast, and performant. That's that's um, that's another part of that's another keystone for what a debugger should do. And there's an interesting thing here in Windows, and it does the notion here is that uh, I mean, as a coder or a person that codes, he's really used to watch what it should be the code into into I mean into the process of debugging, or into the process of seeing what the code is, because you can see here, what Windows does is to have the editor and the debugger joined, and that's really powerful. That's really has um, some good propositions there, or so good functionality. It's nice to have. Of course, it's always nice to have like these key points and breakpoints to let you inspect the code, go forward in the code, go back. Well, we can follow. I think you can't have backward. No, you can just step out. But it's nice to have the code that you really you have like this kind of, how can I say it, this connection with code that a coder has because he wrote the code. So if you this is like the kind of the more traditional way to see the process of you can find like, hey, this is about semantics, like how does, for example, if I step here and I say either, oh, I'm in either, in the whole process, I'm in either. I'm changing the value at this place, at this address space in the process, and I have this state, and then that connects directly to the watch window, and is in the watch window where the magic happens, basically, where you can see here like all the states and the values and uh, all the data itself, and this is important because the thing that I want to get to is that um, it's not necessary, and I would say that this is pretty radical, but believe me on this, because there's some caveats. There's some caveats on having the code here, and I'm just explaining that the good things about it, but there's some caveats with it. And the caveats is not about the just because of the way that you have it. We could go the route and like expose this, we could go the route and have this code, the file, you just dump the file and you can watch it and set the breakpoints and la la la. You have the same stuff going on. But I think the most important thing, the debugger itself is not this. This is not debugger. Debugger, it's this. All this stuff. This watch window, this watch window, this is the debugger. All the debugging process goes here. The powerful thing that Visual Studio has is that he has the debugger and the code itself here, but that's just because of this kind of semantic or this kind of simplistic way of representing or visualizing what a process is doing in a specific time. It's like oh, I'm really used to have this window of watching code and how semantically we are changing data transformations, how we are making data transformations across the process, and you and you're just looking at it, and then you have this watch window which lets you inspect it more in detail, the values itself. But I don't think that's uh, I don't think that's the route we want to go. At least first, I think what I want to inspect first is this watch window, because the watch window is really powerful. I mean, it's something that's means number underrepresented, sorry, and it has a lot of potential to expose graphically and visually all the data itself that we want to do, because there's no reason not to have uh, the code or the data representation to be of a better and real value to us in the watch window. And what I mean by that, it's that probably the watch window itself. I mean, you can see. I mean, this watch window is super simple. It's like well, super simple. But I mean, I'm just saying on the UI, in the UI form of it, that you have just a bunch of tables, and you can watch him add more tables if you like to, and there you go. You know, it's a bunch of tables. You can get the value, name, value, name, value, name, value, name, value. And this is like the simple thing to do. But hey, there's a lot to it in this powerful tool that nobody has extracted, or nobody has seen the value of what the watch window can do. And I think we can go that route. I mean,
And the reason that I want to go this route is because you probably, I mean, we're gonna make a debugger, and the debugger itself, it's contained here. You know, this window has the power to expose visually what right now Visual Studio does. It like segmented and and also in a really not, how can I say, not complete, not a complete vision of the state, if that was, if I can say that. So that, imagine that, I mean, you can see the code here and you can see the values, but you can do more with these values than just watch them, you know, or put it in another simpler, you can do more than just watch them as a tree, you know, like these things you have, that you can have. I don't know, let me get a tree that I can get, for example, either, there you go. And yeah, you know, I mean, this is like a tree state, but this is like a linked list, and it's gonna get you more and 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 more. And you know, I mean, this is the kind of thing that I want to show. You know, it's like, I mean, it's fine, but you know, it can do better. You know, we can do better than this. So the thing, yeah, yeah, that's the reason that I want to start with the watch window first, because I think it's the essence of the debugger. And yeah, I hope that with I mean, all the points that I said, you can like at least understand the point that I got there. Of course, I mean, probably in the future we can. I mean, the whole point of starting with the watch window is because I want to explore the way of integrating visually what a watch window can do and the code itself. You know, I mean, this table, this, how can I say, this table right here and this table right here, they have this kind of deep connection that probably, if we can do it possibly, we can merge them. You know, I mean, there's no reason not to have the values being expressed inside the watch window, you know, or the process. Although, I mean, if you think about it, I mean, the semantics of this is like really nice because, I mean, you understand code, you know, and that's the like the kind of kind of point of view of how the coder sees code, that probably we can do it, because I mean there's too many ways to see code, you know, and that's the main point. I mean, there's too many ways to see code, and we can watch it as a code itself that is executed, with the source code. We can watch it as this assembly that's really the bare bones of what basically the computer is doing. Its instruction is being executed. And for example, there's a lot of potential to this window also. I mean, looking at this, for example, I mean, you have like these kind of, I mean, you know that, I mean, if you know what this assembly, and if you know assembly language, you can like probably understand more what's going on here, and which instruction matches to which set of instructions in assembly. So that's more to it. I mean, you can have semantics here that probably just random and group to do that. If you're really familiar to the thing, you can do something like get groups of instructions that map to one instruction, or I don't know. It depends. I mean, I don't think that's super important. I mean, I was just like saying it because something that I imagine, but it's not important because I mean it's not gonna get you much, and the problem is that the compiler can move the code along all the set, and you can have that problem of trying to find out the groups that matches to one instruction of the source code, and or instruction line, or kind of one expression. Sorry, so one expression matches to one set of instructions, so you have to match the set of instructions that match to one expression in source code. But I don't think that's really important. I mean, the key value here is this watch window. If we get it right, if we start exploring that way, and of course, I mean, the we can start simple. I mean, we can start with like super simple, like this. I mean, and right now, I mean, all the things that I'm talking is just visually, or kind of a visual representation of data. But that's why I want to start simple, because first, yeah, the real problem is the data, you know. So what's the data, and the fun part about debugging is that you're gonna have bunch and bunch. Well, is there fun, and also the caveat, because the data is not, it's not, for example, as in a game, you know. I mean, in a game you have, if not deterministic, at least you have a clear, like a clear image of what the data is in the states, across the states, across frames, you know. I mean, not all the data is going to change all the time, you know, in a game. So you have fixed frames, or coherent frames, you might say, that happens, and that's really nice for performance and two ways of that. But in debugging, I mean, debugging can be crazy stuff. I mean, you can have code that does any kind of ways, or any kind of things, you know, and we have to make, we have to make notion, or make sense of that data that is passing, and that we are like visualizing, and helping the programmer to watch that data in another way, in a better way. So yeah, so that's the main problem of debugging. It's visualization. And yeah, I guess I would say that we couldn't go that route, so let's just start by that. And I'm gonna do the simplest thing possible, probably let's see that we want to probably also, let me finish all this operator overlaying, so because we have it there, and why not. to do them. So yeah, and that, I mean, that was the key point that I want to say state, and is that, yeah, we should like first understand the data. I mean, go for the data and see what the data is, at least for a certain sets. Of course, yeah. I mean, and that's the tricky thing. I mean, we're not gonna. We have to make like this kind of consensus of, okay, what, how does the data, even though we don't know all the data, because I mean the data has to be, I mean the data, it's from the programmer itself, and the data can be defined by the programmer as he wants. Well, I'm talking here like, I mean, not talking about real data, but because that's, I mean, the hardware specific, but uh, the thing I meant is that we have to have a consensus about how we're gonna process that data, how we're gonna pass it to the debugger, and all that stuff. How first, I mean, how we're gonna collect that data, because I mean, that's I think the most important question. How we're gonna collect that, how we're gonna get, how we're gonna even like step into the process, or let the process get sends us that data. How does that's the question that we're gonna start with. So let me see, I can implement this. And this is gonna be, oh no, yeah, this is gonna be a vector, but this is gonna be more like this. mean, probably we can do something fancier later with this. I know. I mean, I don't know how much we are gonna need, like the math itself. Well, who knows? We already use it for colors and fonts, but so we probably want it, even though it's not like such. Well, it's never bad to have. So this is gonna be like this. And then what else? Divisions. I don't know. I think that's good for now. Mm.
So let's see how we can. Let's make a first pass onto what debugging should do. So let's see if uh, So we have this kind of crazy thing. And of course, Windows debugger has to crash. So yeah, this is the Windows debugger that it's more of a generic tool that than going on specifically, you know, like uh so you can see, I mean, we can load a process, you know, launch an executable. These are the modules. The first module that's loaded, well, this is like the search one. So it's gonna grab first the exe, then all the DLLs it's gonna need, which are all this crazy stuff. Those for Windows. And Nano. It seems that it's doing some crazy stuff. We got a breakpoint, but so did I put it here? It seems that okay, but okay, start it again. And now no, let me let's launch EagleFly. '64 fake tune. Time travel backend. No, we don't need that at all. I mean, uh, can this can open binaries itself? Why does these letters are like there? Child processes. Alright. We don't need anything of this. I don't know. Let's open Win32. Let's put a breakpoint if we can. Can we run these like the same way? Like stop again and just enter a cinema process? Yeah. Okay, yeah, something like here. Can I not say it's running right now. How do I know that it's running? It's not even possible to stop it. So there's a debug kip, or this is like an option on the debugger. So we don't care too much about this right now. So this is my thing. We can go the route on using the symbols that the PDV has, but that would be I don't know if we want to do that, or we want to go the route of parsing the binary. Well, not parsing it, but this So we have this kind of useful tool that we can start by, that is dumping I believe this is the way. No. Dump. There you go. Dump the binary. Okay. Let me see. We can start by that. Let me dump the binary. So we have several tools that we can use. Let me see to understand a little bit more. So let me see.
Produce a system error message or error message based on the value entered. Crazy. Now they're storing a SQL server SDF file. Okay, cool. So the object browser basically parses the object files and uh, well, probably he doesn't, but BSC make does it, and this just displays all that data, you know. So this is the whole thing that we wrote, isn't it? we have all the functions. Clear screen. Okay, so I can go in and out, and can I go back to the where is it? Calculate from code point. So these are, I mean, this is they catch also the DLL. Cool. Not just the application itself. And it has the font inbook main is normalized. This is WinMain, writer file. We have B32, so these type depths, which is fine. We have global functions and variables, global using aliases and type depths, macros, array count, and this is the line, the expression. This is the all the macros we have. Renter file, STV true type implementation, number of buttons processed, megabytes, kilobytes, and these are the structures and the enums which are across all the things. It's normalized, it's valid glyph, it's valid font, linear blend, output debug string, so what else can I do? Go to declaration. But why does it let me see if I can. Here's the object browser. Let me attach it somewhere. Alright, there you go. This is crazy. No man, I want my, where's my solution? Namespaces. So this is more statically, you know. The object browser works statically with the symbols that it got from compilation, or not even. I don't know if it works with compilation, but oh yeah, because they are the objects. They grab them from the object files that the compiler made. So this is more like, I mean, he doesn't care. The object browser just gives you the whole thing, you know. It's like it doesn't matter if it's if zero out or whatever. Which is fine. So it works more statically. Macros. Okay, cool. So we can use this. We can go directly to the bill, and let's say that we want to uh, or we can have it right here, I guess. Let me close this because clearly there's a problem with it. No. So it's more like this. Okay. So let's go here and go to and we have 2 PDB solution. We don't have any ASPR. So we put it like this. We don't have
the SBRs. Socially, well, am I looking it wrong? And probably it's in the. Yeah, there you go. I'm sorry, we got it wrong. So we have a SBR for Win32. We have a SBR for EagleFly, which is fine, but we don't want it there. So there you go. And yeah, so this is more like right there, no, isn't it? Right there. So if we go right here, shouldn't be anything. If we go to build, and there you go. We have a SBR for EagleFly and an SBR for 132 EagleFly. And now we can call BC make and what? The SBR files field specifies one or more SBR files created by a compiler assembler. Separate the names of SBR files. The spaces or tabs you may specify extension. There is no default. we can have something here like we can do something like this has to be like this. Let me delete. Okay. Okay, we don't have SBRs at all. uh, okay, so this is like this. And well, if it's not possible, I'm gonna keep it right here. Okay, so we go to the, we have SBRs and we have an BSC and an SBR, and the BSC is called Win32 EagleFly BSC. Alright, we got it. It took a while, but we got it. So I don't think we want to keep these things, so I think I'm gonna do it this way. There you go. So now how can we use this thing? Is it in the object browser? Okay, so it should be on the object browser, which is right here, and I don't see anything more there. Resolution, I mean it's the same stuff, but it's the same. So I mean, the VC make I mean just makes it, but now how can we read it? Or should I mean this is the whole data, I think. But I didn't need the VSC to look at this data.
So I think I know that BSC fast lets you like do this, like go to definition, stuff like that, which is fine. But let me see. Okay, I will open this. And I want my solution. So now I don't have the whole structural thing that I had before. Okay, so I mean, if that's it, well, I don't know. We will have to check that a little bit more. I mean, this is not the whole. I mean, this is not where I mean the point to parse it, but I just wanted to have some reference and to look at some. I mean, how does some programs extract all these data, and how can we uh, and see if we can like understand and learn something about this using this uh, what Windows uses or what Windows does, you know. So yeah,
I mean, this is just the starting point, and we will need to continue doing this stuff, and hopefully we will get to a point where we can extract some data and make sense of that data, of course. So yeah, I think that's good for today. And yes, so please, if you would like to ask some questions, feel free to ask them on YouTube or Twitch or on Twitter. And yeah, for today that would be it, and I will see you all on the next stream.